Thank you, everyone. Thank you for staying put after the lunch session. Beautiful lunch. Uh, so I'm Rahul Jadhav. Let me start sharing my screen. Okay, so a bit of a background about myself. I'm Rahul Jadhav, co-founder, CTO for AccuKnox. My day job, basically, I'm a developer. Been into product and engineering for past 25 years, working on Linux kernel primarily, uh, for network and transport optimization primarily in my past experience. Uh, in 2019, when I met Nat, the co-founder and CEO of AccuKnox, I mean, there was a glaring problem statement that that was staring at us in the in the eye. Like, all of these workloads are getting deployed in such an ephemeral ways, in such a dynamic conditions, and there was no clear way of securing those things. So we decided to do something about it. Our primary the journey for us started by thinking, how do we do it differently? Like, there were so many attack frameworks out there, like MITRE attack framework. Edwin talked about ransomware attacks. How do you take into consideration these attacks and secure for those attacks at runtime? So that became our primary problem statement. That's where we started looking for. And then we looked at existing open source tooling, and we realized that most of these toolings were operating on a philosophy called as detect and respond model, or post attack mitigation, as they call it. And we saw that, if you adopt that kind of philosophy, you won't be actually be able to protect yourself from attacks such as ransomware attacks, right? By the time you do a detect and respond kind of model, by the time you take a remedial action, the damage must have been already done. So how do you secure your solutions in an inline mitigation way, doing an inline mitigation where you prevent the attack from happening in the first place? So that's where our journey started from. Uh, that's where the open source that we started working upon. And again, you know we took a radically different approach, and we were not sure about this approach will scale or not, so we decided to keep it in open source and see whether we get an industry opinion and experts opinion out in the open source. So that was the best way for us to capture this thing. Someone advised us to go to CNCF, and then when we went to CNCF, actually it was really a great experience. I think that was one of the most important decision that we took as an organization to go the CNCF route. Two things happened. One is we got advice from CNCF team members or TOC saying that some of the approaches that have been tried before. So they actually pointed us towards some of the projects, some of the people that had been working in the similar space and faced certain problems, and we told them how we are trying to do it this and how we are trying to do this differently, and why will it not face those problems. So those initial discussions were of extremely uh, you know extremely technical, but they were on that journey with us. So that was extremely useful for us as an organization. The other important step that we took as an organization was to go the full Kubernetes route, like 100% Kubernetes. We built all our systems on Kubernetes. So 100% of our SaaS and even the on-prem deployments that we do is completely on Kubernetes. So these are the two decisions that sort of paved the way for our organization, AccuKnox. And you know one of the other mindset that we had right from the beginning is that, like I said, inline mitigation. How do you prevent rather than detect and respond kind of model, wherein you should be able to say allow this set of actions and deny everything else. That's the basis for any engine which has to necessarily do a zero trust model. Like, it could be a CNI where you say allow this set of traffic and deny everything else. But you need to have that kind of policy engine in place versus where you have a policy engine which says if you find this, take an action in as a response. Once you have that kind of model, you don't really have a zero trust model. Once you allow an attacker to actually execute their code in the target environment, it's game over for you. That's what we realized, and that's what we built towards. That's where KubeArmor came into being. And then once we had the policy engine built, we realized that, Okay, building a policy engine is one aspect. Getting to zero trust using using a policy engine is a different problem altogether. It requires a lot of other things to fall in place, and some of those things is what I want to bring today to the for this discussion. All right, thank you. Thank you. I mean, just for the unprepared, a quick definition of zero trust. Uh, and I'll be concentrating primarily on the cloud native deployments. Of course, there is zero trust comes in all shapes and sizes, from endpoints. How do you secure the endpoints and all of those things? I'm going to primarily talk from the cloud native perspective. Now, you might collect a collection of concepts and ideas designed to minimize uncertainty in enforcing accurate least privileged access decisions in information systems and services in the face of network viewed as compromised. So two things uh, stand right out of the frame here. One is having least permissive policy mode, least permissive access mode, and what does it actually mean to have a least permissive access is what I'm going to touch upon to some extent. And the second part is you have to assume that at some point in time, whatever you do, attacker is going to get into your system. That's a given. So how do you reduce the how do you make sure that attacker won't be able to maneuver within your systems? That is something that if you have a true zero trust solution in place, you'll be able to limit that maneuverability. So that is where we have been focusing upon. And this again, this is definition is from NIST SP 827 architecture document. So when we talk about least privilege access decisions, which are the different places where this access decisions could be made? And there are multiple of those, right? I mean, there's no one right answer here. You can do it at the network access level, where you say you have a communication graph of your microservices. You want to allow this microservice talking to this other microservice, and that's a very popular model. It's called network microsegmentation, where you identify dynamically which all microservices need to talk to other microservices. Again, there are a lot of repercussions on the performance and all the other things while you're doing that kind of instrumentation and monitoring. So you'll have to keep you'll have to keep a tab on that particular aspect. But network access is the most famous. So whenever anyone talks about zero trust, they will most likely talk about network microsegmentation or network based least permissive access, and that's been out there for quite a while. But then we realized it's not only about that. You need to do a lot of other things. API access is another thing that has been very popular. You have a service mesh. How do you ensure that these microservices talk to this other microservices and only on this specific API endpoints? And how do you identify those dynamically? One of the biggest problems that we have seen is that users are not willing to put in that effort. Or let me put it the other way. Even if they put in that effort once, it's fine, but they are not willing to put in that effort all the time, because applications are changing, policies are platforms are changing. So it's a dynamic environment out there. So even if you end up achieving a zero trust at a particular point in time, you won't be able to maintain that posture over a period of time. That's a bigger problem. So API access is another problem. Service mesh typically deals with it. Identities and entitlements, that's another big problem. We have service account tokens. We have multiple services that are there in Kubernetes environments. And those services need access to other services, other resources within the Kubernetes environments. And those accesses are enabled through identities and entitlements, through service accounts, users, cluster roles, cluster role bindings, and all of those things put together. How do you make sure that you have a least privileged access towards those aspects as well? The fourth thing is system access. Again, this is explicitly noted in the NIST guidelines that you need to have a hardened system. But what does it actually mean to have an hardened system? One thing is, your pod is an execution unit in the Kubernetes environment, which means that the attacker has direct access to your pod. The connection ends up on your pod. Your pod is directly, responding back to the connections to the user's connections. Traditionally, it used to be virtual machines. You used to have an application or process on a virtual machine, but these days, with Kubernetes orchestrated environments and containerized environments, it's the pod or the container which is directly facing the attacker and the outside world. So how do you harden the pod? And what does it mean to harden the pod? One is, within a pod, you have multiple containers. Those multiple containers might have multiple binaries. You have a set of volume mount points within those pods. You have multiple binaries trying to access, do network access. So there's a lot happening within the pod itself. How do you ensure that you create a least permissive privilege policy there? What I mean by that is, how do you ensure that you only allow certain set of processes to execute, only allow certain processes to access certain volume mount points? You don't need all the processes to access all the volume mount points. Now, imagine what an attacker does when an attacker gets into a system. The first thing that the attacker has to do is initial access, as per the MITRE attack framework. Initial access is the first point, wherein the attacker tries to get into your system by exploiting a known vulnerability or a zero-day attack or something like that. But once the attacker is into your system, the second thing the attacker is going to do is reach out for credentials, access tokens, volume mount points, your data points within the pod. The next part is they're going to connect to the command and control servers, sending beacon messages. So they need network access. So at the bottom layer, right, any application, including the attacker's application, need access to certain fundamental systems primitives, which are essentially access to network communication, which is essentially the ability to execute a process, that process having the ability to access certain key resources within the pod itself. And that's where the systems hardening comes into play. That's systems access for here. And then the data access. So the data access is basically within the pod itself. You have all these volume mount points and you want to restrict access to all these volume mount points. But it's more than that. You have MySQL database. You can have SQL database users properly configured so that appropriate users have appropriate level of access. So all of these put together, and again, there are certain other dimensions as well, which can be used here, but I've just quoted in this 5 dimension. And then there are 2 other points that the NIST document mentions. One is you need to have an identity. Now, an identity is of course, in the zero trust solution, identity is the perimeter. Right? That's what everyone talks about. The primary problem that we have seen in the context of identity is how do you manage identity at a multi-cluster level? That's where one of the problems comes into play. Like you configure a service account token for a given cluster, but you have 100 other clusters. How do you properly configure all this? How do you have a way such that your workloads can talk to each other and still have authorization policies based on these identity, on a specific identity solution, which is well governed? So that's one point. And then the granular visibility. Zero trust says that you have to have visibility into all the executions and all the traffic that is happening within your premises, within your workloads. So which means that you need to have some way of getting that kind of alerts, telemetry, information across all of these workloads. So that's another key point of from zero trust perspective. Now, when we thought about some of these aspects, right, and again, this is a overloaded diagram. I'm going to distill one thing at a time. So this is the zero trust architecture that we have in place, what that allows you to do things at multiple layer. And you need to have, like I said before, multi-layer zero trust is one of the important aspects to securing your solution. If you secure a solution, if you secure your solution at just the network layer, let's say for example you have network microsegmentation in place, and let's say there is a known vulnerability in your existing workloads, which means that known vulnerability is exposed on well-known ports itself, which means the attacker would be able to make use of that known vulnerability and get into your system. The assumption here is that let's consider the fact that the attacker has a way already to get into your system. If you make that assumption and then design for a solution, that basically paves the way for zero trust architecture. So there are a few things here. One is the identity and entitlement management. That is pretty clear. You have Kubernetes identities and entitlements. How do you make sure that it has least permissive access? Now there the challenge is, one, you have access to all the metadata in terms of service account and rule bindings and all the other things. How do you get visibility into what access should actually be enabled? That's the primary challenge there. The second part is network segmentation. Again, network segmentation requires you to have information as to which workloads are talking to which other workloads, which means that you need to have forensics or granular telemetry from the network side of things as well. How do you get that? The third aspect is, I've mentioned here process whitelisting, which means that you need to allow certain set of processes to execute within your pod. But which set of processes to execute within your pod? Your users, the DevOps team member or DevSecOps team members are not in a position to actually manually identify any of these things. There could be only a bunch of processes out there, but one of the process might be executing at the end of the week to take a backup, let's say, for example. So it's not possible to do all of these things manually. So how do you do process whitelisting, wherein identify a set of processes which which should be allowed in the target environment? The third thing is process-based network control. Again, this is an interesting concept because this was introduced to us by one of our users who first pointed out that, I have enabled ingress access, but I don't want to enable ingress access for the whole pod. Only this binary is should be allowed to use any of the network primitives within this particular pod. So we said that let us check what kind of primitives are available and if we can do that. And we realized that there are certain primitives available in the kernel space which can limit this kind of access. So what eventually happened is that we now have a way to tell the solution that only allow these set of processes or this one or two processes to do network communication, have TCP, UDP, ICMP network access. So that's another thing. Restricted access to sensitive assets. Again, this has been a traditionally hardened systems have been making use of AppArmor, SE/Linux like LSMs to harden their solutions. Military grade, most of the time it's made use of in the Department of Defense. And not only Department of Defense, even Red Hat Enterprise in Linux by default ships with SE/Linux policies. And most of the time what happens is, if something fails, it's blamed onto SE/Linux. And that gets turned off, right? And that's a well-known problem that everyone faces. So it gets converted into permissive mode, then it gets disabled, and so you leave with a system which is really vulnerable to external attacks. What we thought was that the primary problem here is not that the primitives are not available. The primitives are not serving well today to the users. So what we decided is that we need to make use of the same primitives, but should make the user interaction to those primitives through a Kubernetes layer. And that's what essentially KubeArmor does today. So under the hood, it leverages all the LSMs, Linux security modules, AppArmor, SE/Linux. BPF LSM is one of the primary LSM that we are leveraging. And now that is the flagship LSM that we are leveraging today. That is essentially the secret sauce. And in some ways, we got lucky. The reason why we say we got lucky is because when we started our journey in 2020, like 5% of managed cloud provider space had BPF LSM enabled by default. In 2021, it increased to 50%. Today, it is at 95%. And that basically changed the whole thing. So we came to a realization that just the way eBPF actually deprecated IP tables, there is a real possibility here that BPF LSM can deprecate SE/Linux and AppArmor because it is so difficult to use. In a single sentence, if I have to explain what BPF LSM allows you to do is, it allows you to convert user-specified policy into eBPF bytecode, which can be injected at LSM hooks, which are enforceable, which means it's not just for observability and monitoring, but you can actually enforce controls them. That changes everything. That's what, and KubeArmor is the first engine to actually leverage that kernel primitive. Then there is granular monitoring. Again, granular monitoring has been already been taken care of by a lot of other projects, including Pixie, including there are a lot of other projects which can do eBPF based observability monitoring. The way in which we differentiated is that, or QBarmer differentiated is that it did two things. One is it takes into consideration security specific aspects of monitoring. So rather than putting hooks generically across all the K probes or K-rate probes in the kernel space, we target specific security sensitive probes so that we don't induce much performance overhead. So that has been one of the primary aspect. The other aspect is how much of aggregation you can do in the kernel space itself. Every time there is an access, if you push that access to user space, it's going to impact your performance. That's a big problem. Most of the engines out there suffer from that performance problem primarily because of this reason that every time there is an event, you're making a user space context switch and then pushing the information to user space, and that's what is causing most of the problems. The other interesting project that has been developed as part of QBarmer is KTLS, or it's pronounced as Cattles. What it does is, using Kubernetes, now you have a standardized way of enlisting all the services within that particular Kubernetes cluster. How many of those services are secure or insecure? How many of those are using plain text communication? It's extremely difficult to find it out unless you deploy something like a Istio service mesh, which can of course tell you, but then to deploying Istio service mesh just to get that visibility is too much of an ask, right? You are injecting a proxy to just get that kind of visibility. So what we decided was, we need something which can give us that kind of visibility. So Cattles is that engine which enlists all the Kubernetes service endpoints, checks and tells you how many of them are using secure communication, how many of them are insecure. If they are using secure communication, if they are making use of the right TLS protocol, if they're making use of the right cipher suites, signature algorithms, if the certificate configuration is appropriate, all of that you get in a single, in a single job. In 30 seconds, you get for a complete Kubernetes cluster a security posture which says that these are the services that you need to tackle, from security point of view, which are using insecure communication. And then securing the secrets. Securing the secrets, that's an ironic term, but lot of times what happens is that you have secrets managers in place, and those are great. But eventually, when the application developer uses that secrets, the application developer ends up keeping it in the temporary file system, file storage, and you are at the behest of your application developers' security skills. And that's where these are some of the aspects that we have targeted. We have seen these as the primary pain point in most of the organizations, and we decided to build towards this. And the biggest point that we had in mind was, how do you ensure that the user doesn't have to manually specify any of these rules? So you have to have a visibility engine which can give you that visibility, which can give you this security posture. So what are the challenges that we have faced? One is, what is identifying the least permissive policy, right? What is the least permissive policy? Least permissive policy, you can go to any level of depth, right? You want to allow what file system accesses, for every process, every file system, for every file, at every file level. You don't want to get into that complexity. So we had to decide. The first challenge for us was that, how do you define what would constitute as a least permissive policy for a particular dimension? And there were a lot of, I can't go into the details of all of these decisions that we had to eventually make and how we arrived at some of those conclusions. But if you're interested, let me know separately. The second part is dynamically identifying the policy requires observing the workload, right? And that means inducing performance overhead. How do you ensure that the performance overhead is kept to the minimal? That's another big problem. The other biggest problem is, or challenge is, you have a security zero trust policy in place, but within a week's time, the developers are going to make changes to their application, which means that the least permissive policy is no more in effect, right? How do you make sure that your application updates and your policy updates are synchronized? That's a very big concern in the zero trust world. platforms are updated. Not necessarily the application, but your Kubernetes platform itself might get updated, or some other libraries or some other base layer in your solution might get updated. So how do you maintain the zero trust security posture with that? Reducing risk of application downtime. Of course, the biggest problem with zero trust is you are allowing this least permissive behavior, but if you are not able to actually identify the least permissive behavior in a proper sense, you have the risk of application downtime. None of the users, none of the CISO is going to get fired for not putting the zero trust policy in place, but they will surely get fired if they put in a policy in place which is going to cause application downtime, right? So that's a bigger problem than one can imagine. And UX, when new rules needs to be updated in the policy, like this is a big problem. Users need to update their policy. The policies have to be updated along with the application updates, but the UX, the user experience, has to be really, really smooth there. So that's another big problem. I've already talked about multi-cluster environment. Like the biggest problem with multi-cluster environment is identity provisioning. So unless and until, as an organization, you have thought about properly having an identity provisioning scheme across all your workloads, which works regardless of the Kubernetes cluster in place, you don't have a strategy. And that's the first place where you have to start with your zero trust journey. So one of the issue that we identified about reducing the risk of downtime is, again, this is not something new, where you have a policy in place, applications are updated, and then the application updates results in policy updates. Now those policy updates have to be captured before you put policy into default deny mode. This process has to be in place, and to support this process, you need to have an appropriate toolchain. So you need to have a toolchain which can provide you with dry run and audit mode. Most of the policy engines do support it in some shape or form, but what we have observed is a lot of times you need flexible control over this dry run mode. For example, you need to be able to say that these namespaces should be kept in default deny mode, but these namespaces, since they are more immature or more consistently updated, they can be in default audit mode for a certain duration of time. That kind of control you need over the framework, and that was one of the pain points that we had identified. Now, dealing with application or platform updates, like I've mentioned before, one is you have policy that is getting discovered, and this again I've captured from one of the internal architectures that we have. You have a policy that is in inactive state, which is discovered. How do you decide when that policy is stable? That's one of the biggest problem. Different applications, the stability time is going to vary. Some of the applications might take weeks to actually get a stable policy out of it. Some of them might get it in 2 days or a day altogether. But then so at some point in time, the user decides to apply the policy because they are not seeing any alerts. So you put that policy in the active mode. So in the active mode, it can be enforced in default audit mode or default deny mode. How do you make sure that during that particular process, if there are any changes, if there are any application behaviors that have to be taken into consideration for policy updates, how do you have a user experience which can take into consideration those policy updates? That's a bigger problem. Then once the application is updated, you might have to put the whole application in what we call is a shadow time, which means that it is in audit mode for a certain duration in time before we can put it back into default deny mode. All of these decisions there are a lot of specific points that there are a lot of internal design discussions that have happened on all of these aspects. But without this solution in place, without a framework in place, without a proper UX in place, your users can't consume zero trust. It's much easier to say you have a zero trust policy engine, but that policy engine cannot be consumed unless and until you have a process in place. And then trusting the zero, how do you verify the efficacy of zero trust policies in place? So organization ideally have blue teams and red teams. Blue teams are defense teams and red teams are attack teams. Not all organizations might have it. Some of the organizations use MSSPs to do all this kind of work, but you need to have a framework in place which can do this where you have a deployment, you have two teams operating in isolation who can then uh, tackle the same deployment. One is defending it, another is attacking it, and then you should have a way of measuring the attack and defense efficacy. You should have a zero trust efficacy report in place, which then becomes a feedback for your further iterations. Again, there are a lot of caveats about what I'm saying. The point being, the one thing that I will have, if I have to tell you to take home, is you need to have all these things in place if you are on your zero trust journey. You need to have a way in which you have a framework which can actually take you from zero to zero trust. Second is, even if you move towards zero trust, you have to have a periodic checks and balances about the efficacy of your zero trust solution in place. And how do you do that is not an easy problem. So in summary, a lot of times it's not a single switch turn on button for zero trust. You will have to do it incrementally, targeting one namespace at a time, one workload at a time. It's going to be, in a lot of cases, if you don't have the right tools, it's going to be really, really painful. Uh, and your team might really, really resist. But, in some cases, there's a government mandate, as we have seen in the case of 5G security, that there is a government mandate uh, for having zero trust security plan in place. So you'll have to eventually reach towards some of these things. The second part is zero trust puts additional onus on ensuring that the policy updates are synced with application updates. This is a very difficult problem. This is the problem which causes everything to be turned off by default. And if you get this problem solved to some extent, that would make sure that you will have a consistent zero trust security posture for your workloads over a period of time. Yeah, and then the last but not the least point, zero trust cannot be achieved just by having a least permissive policies or access settings at a particular dimension, be it network or be it API. You need to have it across multiple layers. Without that, you cannot really have a strong defense and depth approach. Yeah. So thank you. That's about it. Thank you very much. Any questions? Yeah, Ram.
Hey, hi. First of all, a great presentation.
Thank you.
And so I have one question related to because okay, just to introduce myself, I am Abhishek. So I'm from NetApp. So about my background, I have done CKSS as well. So and I'm into cloud native world. I promote it. So and I work with a lot of vendors also who are onto EBF, and EBF is becoming a great thing because they say we'll reduce your container size by using EBF technology and reduce the number of vulnerabilities in the in the overall container size. That's the thing which is happening right now. So my question is more on like on the Kubernetes world, there we have security context and capabilities which can be set
Yeah.
for the for the every pod or at container level.
Yeah.
So do you still believe that that doesn't suffice and we have to still go ahead and use EBFs? Because what I am aware, I might be wrong also, like EBF does not support ARM based ARM 64, does it? It only supports x64 based Linux kernels, is what I know. So my question is more like, is security context and capabilities not enough to achieve?
Fantastic question. Thank you. Thank you, Abhishek, for bringing that up. Very great question. Great question. So Kubernetes already supports something called as security context, using which you can specify app armor policy, SLNX policy, and capabilities, set of capabilities that can be allowed by that particular workload. Now, the primary problem that we have seen is that this app armor and SLNX policies have to be specified in its native format. And like I said, Abhishek, before, it's not that the users don't want to secure their system. The problem is users don't know what is it that has to go into the policies in the first place. So if you ask users to actually specify SLNX policies natively as part of security context, and tomorrow the application is going to be updated and you have to change it, try to put that whole process in place, it never works out. And that's the reason why today no one is using security context SELinux app with SELinux and AppArmor in native mode. In fact, this is one of the things that was been put forward to us by the CNCF team. They said that it's not like LSMs cannot be consumed by Kubernetes today. The problem is the user interface, the user experience. You know, applications change. The second part is users are used to specifying the policies in YAML format, and under the hood they can you can put in all the complexity. So that's the vision that we started off with as well. So if you look at us, we are not doing something radically different. We are riding on the giants of shoulders, shoulder of giants. That's a good one, right? Yeah. So uh, AppArmor and SELinux have been existed for past couple of decades, and they've been hardened in Linux kernel. They have been, it's been used across everything. Containers natively allow you to specify AppArmor policies. Kubernetes allows you to specify AppArmor policies as part of security context and capabilities. The problem is, how do you get to that stage, right? So that's a bigger problem. The second point you raised was about the portability aspect, right? Like, so what eBPF is portable. It works on ARM as well as x86. We have found certain portability issues with BPF LSM. And those issues are solved in kernel version for 6.2. So it's still not ripe for adoption for ARM platform. But what the solution that KubeArmor has is that, depending upon the platform used, it internally orchestrates what primitives to be used. So AppArmor SELinux generally work across all the platforms, but they have certain limitations. So depending upon the policy that you're using as input, KubeArmor internally decides what is the right approach to be made use of, and that essentially is another point. That is another pain point for users. They don't want to orchestrate with all these SELinux and AppArmor manually. The other problem with the security context is that all these LSMs, we have done a big study on this. So I have I can talk about this for another 1 hour. Okay. So, but just one more point. Different distributions support different LSMs. Container optimized OS supports AppArmor by default. EKS, Bottle Rocket supports SELinux by default. RHEL supports SELinux by default. Something else supports BPF LSM by default. So as an administrator of the Kubernetes environment, you have mixed node clusters. You won't be in a position to specify this security context manually. Again, a user experience problem. So that's again solved by KubeArmor. Great question by that. Thank you. Yeah, Arvind?
Hey, Rahul, just to beat to death security context again. So particularly from the OpenShift angle, right? I mean, this is what we are seeing most often is when you create a namespace, right? And OpenShift by default gives you a UID, GID, and FS type range. And, and sometimes when you want to bypass that, people just go patch it, right? OCADM, add any UID stuff. So do you have any sort of policies or governance around that? Because, people just take it for granted and just say, hey, allow any UID and run it. Or the same thing could be for privileged execution, right? I want root user access, so I'll just flip it and I'll run it that way. So what's the governance model? Because as such, OpenShift doesn't really lock you down at that level.
Correct.
If you've got a service account that can do it, it does it.
Correct.
But how do you literally flag that down and say, hey, somebody went ahead and did this? Or I have a policy in place that's no matter, even if you have the privilege, I need a bypass or a secondary approval to go about really approving that change or locking down that UID GID range.
Correct. Great question again. So the question is, you have all these UIDs. And, so typically, traditional Linux has something called as discretionary access control, right? Where you have users, but you have root users surpassing everyone else. So you have a privileged attacker in place. The attacker can cause complete mayhem. So we recently introduced one feature called as wherein you can enable every process or every file on the file system path has its owner. So in the configuration, you can specify that allow only this owner to execute this particular file. So that way, even if there is a root user trying to execute that file, that execution won't be allowed. So that is over and beyond what standard traditional, so that this was something that was requested by one of our users. So we built towards it. That's again a great point. Yeah. Yeah, Ram.
I am Ramkumar, primarily working in telecom development security. So I have two questions.
Yeah.
So one is, do you see a need, or at least I'm not aware, like CNI, CRI, do you see a need for a standardized framework from CNCF to bring all these together? That's my first question. Second question is, where do you think the cloud native security is going? People are talking about confidential containers, WebAssembly. So where do you see the trend going?
Wow. So, I mean, this is a great audience, frankly speaking. Great questions. So, first is a standardized policy language. Like for Kubernetes network policy, you have to specify an ingress egress rule. There exists something called as Kubernetes netpol, right? Wherein you can specify standardized language. I wish there could have been something like that for systems hardening as well. I think this is something that the community can work towards, but this is an open action item, frankly speaking. This is a big gap. So there are policy engines in the form of Falco, CubeArmor, Tetragon, defining their own specifications, and it's going to lead to more confusion. I think over a period of time, there would be someone who will come in and solve this problem. But we have a different take. Rather than standardizing the policy language itself, what we are doing is we are taking a different approach. We are implementing operators who can take intents from the user and then convert it into, depending upon what is deployed in the target environment, it can convert it into the appropriate policy language. So that you don't, because standardizing a language has failed in the past. Have a look at service mesh interfaces, SMI class. Like, you have SMI classes, SMI interfaces. Uh, Service meshes adopted to some of those, not adopted to all of those. You take example of Kubernetes network policies. Today, you still have Cilium network policy, Calico network policies on top of Kubernetes network policy, because Kubernetes network policy cannot keep up with the improvements of these individual CNIs. The same is true even for this aspect. So we have a slightly different take there. Rather than standardizing a policy language there, you should have a standardized security operator. Look at what security operators have done for the storage world. Extremely simplified it. Like, for security, there doesn't exist something like this. And this is the work that we are doing in conjunction with Nefio. I'm not sure if you have heard of Nefio. Nefio is a Google's initiative for telco domain automation. We are engaged with them as part of NSF contract, a National Science Foundation contract, where we are building a security operator which will take intent as input and convert it into appropriate format. Great question. The other point you raised was about confidential containers. Again, a great point, because whatever you do, you are still at the behest of the privileged attacker, right? Like, privileged attacker, if they get into your system, they can still turn off the knobs. You're still operating at the software layer, right? Like, confidential containers provide you with that ability to not have that. So we are working towards that as well. So we are trying to check what is the best way in which we can work CubeArmor discovery engine together with the confidential containers. But the problem that we are facing is that those pieces are still very early in their life cycle. It's not mature. They don't work equally well across all the environments like Azure, Nitro on AWS and things like that. But yeah, eventually the world is going to move towards confidential containers for hardware-based security.
The gaps that, let's say, if there are certain configuration gaps at the node level which you detect, right? And obviously you have intelligence to kind of rectify that, and which is what you're talking about as intent driven approach. But do you also churn out events related to these misconfigurations? And going back to the standardization part, I don't know how Falco does it, but is there a way you can standardize those which can then be taken up by someone else to have a remediation action done? Of course, you may or may not like it, but
No. It's and this work is already done to some extent, right? Like policy CRDs is a work in that direction, is what I feel, because that allows you to standardize. AWS has put in the standard definition of alerts as well for file classes, process classes, and all these things. So eventually, the world will move towards that. CubeArmor is already supporting policy CRD. we will support AWS standard alerts format because we want it to be consumed by AWS Security Data Lake. So yeah.
But today, the semantics of Falco may not be same as CubeArmor.
Correct, but most of the fields are similar.
Okay.
So, but yeah, the native format of Falco is very different from native format of CubeArmor, but there is an overlap of 80%, I would say.
Okay.
That
That's
I would
good.
say, yeah.
All right.
So,
Thank you so much, Rahul, for the.
am I audible? Sorry, last question.
Sure, sure.
So, somewhat it is related, like in the context of if we talk about product security, I mean, pod security policy. So, App Armor, I mean, not App Armor, sorry, Cube Armor, is it integrated with the PSP? I mean, at the back end, it is utilizing the PSP policies, pod security.
No, 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 no. We're not utilizing PSPs in the backend. We are directly dealing with the LSMs, Linux security modules. We are using BPF LSM and eBPF.
So, is there any roadmap for the integration?
Oh yeah. So one thing that we have in mind is so apart from doing systems hardening, right? Like a lot of users are asking for a lot of things. Now once you have an eBPF layer, we have been getting questions about can you support traffic decryption using uprobes? Again, it's not related to systems hardening. It's about decrypting the SSL traffic, right? Like not decrypting the SSL traffic, but observing the SSL after. So yes, these things. Is there any specific use case you have in mind that because this is a very interesting topic. One thing that CubeArmor team or maintenance team has decided is that anything which relates to which cannot be handled by CNI or a service mesh should ideally be handled by CubeArmor if it falls within the realm of pod. So yeah, and if there is a we have a roadmap section where you can just add in a section if you are interested in looking at getting something done.
And is this the same like OPA gatekeeper?
No. So OPA, Kyverno are admission controllers.
I
So
mean, integration is there, like again, the roadmap.
yeah. So one thing that we have tried already is that now OPA or Kyverno, they are policy-based systems. Like you need a policy which says that if these are the prerequisites before the workload should be allowed to before the workload is admitted, right? But what should those prerequisites be? That comes from runtime visibility. So what we have done in the past is that CubeArmor gives you that runtime visibility. Using that runtime visibility, we can pinpoint you that these are the Kyverno policies that would be specifically effective for you. So yes, that is the work that we have done before.
Okay.
Yeah.
Thank you.
All right. Right. Thank you so much, Rahul, for the wonderful talk. As a sign of gesture, NetApp team wants to facilitate with gift box for you. Yeah.